Yeah, this morning, we're going to look at the DVM 2130. We'll mainly focus on that, which is our standalone DVM that will connect up via Bluetooth to tablets. And then we'll look at the FDC DVM module inside of the FDC app. So the 2130, well, a little background on this. This was designed in-house. The first one that we had came out was the DVM 1100, and that was for the QX. And then we have the DVM 1110 and the DVM 2130, which is for our and FDC, other FDC products. It was built with CP in mind. Very high accuracy. So that was the whole design of it, was going to be built around CP industry. This one does have a built-in GPS for both location and timing. So if you're doing interruption, the location is it's a 2 to 5 meter accuracy on the GPS. It's consumer grade. It pretty much matches what your phone is. There is really good filtering on this that was designed into the circuitry. So any type of AC noise or any other signals are going to be filtered out on this. It is sealed, so it's made for being out in the field in harsh conditions. And it does connect via Bluetooth. So you don't have to have it right there with your tablet. If you don't, if you need to set that by where you're taking your measurements and go sit in your truck, you can within 30 feet, whatever the Bluetooth is, and that is for the 2130 only. With the USB-C cable. And if you're out in the field, this should get you, a good full day of measurement. If it's starting to get low and you're still doing your surveys, you can hook it up to your Mesa tablet via the USB-A on the Mesa, and the Mesa tablet will charge the DVM out in the field. The inputs for this is a standalone, and it has several inputs. The first one is the remote trigger. If you are using our survey probes or the data cane, the button on there, that's where this will trigger the reads. We have a voltage input, we have the common, and then we have a shunt input. So like I said, this, if you're doing pipe to soil, which is AC or DC, you will be using that red 250 volt input and the common for your reference cell. When you are measuring a rectifier, like the rectifier output volts, you will use that red input and the common, that black input, to get your voltage. You will use the shunt input, the blue, to get the measurement across your shunt. We are measuring millivolts across the shunt and converting that to amps. So some of the specs on this for DC and AC, the range, we have the 500 millivolt range, which is going to be any type of current field, any type of a bond, anything you're measuring a shunt, you're going to use that blue 500 millivolt input. We have a 5 volt range and a 250 volt range. Those are all have an accuracy of 0.1%. For AC, for any type of AC current, that's a 350 millivolt. And then we have the 3.5 and the 175. And the reason those are not 250 is for AC, you're actually measuring AC RMS. if you have any questions on that, you let us know. But for RMS, you're not getting your peak to peak. So 250 peak to peak is going to be about 175 volts for RMS. The input impedance on this for CP, the standard is that you have at least 10 mega ohms or greater for any type of CP measurements. This one is at 100 mega ohm input impedance. Again, this was designed for CP. So if you're looking at that, a meter, what you're reading from your meter versus the actual true potential, if you run it through the formulas on this, just for a comparison, VM is going to be your meter, your true voltage, ET, RM is your meter input impedance, and then RT is the rest of the external resistance of that circuit. So if you have a DVM that is a 1 mega ohm input impedance, you're going to get a little over 9%. You can get a little bit over 9% error. If you're using 10 mega ohm, which is the minimum that you need for CP, you're going to get about a 1% error, and that's good. What we have is 100 mega ohm input impedance. If you're doing that same circuitry, that's where we're getting that 0.1% accuracy on that. We do calibration in-house, and when we say we do calibration, we actually do a calibration. This is not just a verification and we'll send it back to you. This is run through a program that measures multiple ranges, and if any range is anywhere out of our spec, we will adjust it and get it back into the range. So it is a true calibration, and you get a certificate of that calibration with all of the ranges that have been run through. If you want to see what your calibration status is, if you go into the settings and the about, then you will see you'll have a calibration date. So, and that's good for, like I said, those are valid for 1 year. We guarantee those for 1 year.
Hey, Lon, real quick,
Hey,
we have
Lon.
some questions. So one from Sergio was, do you need to have AC, is AC filtering required when doing CI surveys with the DVM?
You can pick up noise, any type of stray current from anywhere from, it could be AC. Yes, it will filter out that AC for CI if you're doing CI CI surveys.
And then Paul had asked, what is the filtering that's actually happening in the DVM to remove those undesirable signals? What type of filtering is going on?
That will have to get with the developers of this, the engineering team, and we can get you the details on that. If you can hang on, we'll send you any type of details you have on that question. So if we're going to connect to the DVM to in this instance for our Mesa tablet, you have two options. So the first option is just to open up the DVM module. It's pretty simple. It's an easy way to go. It's the way I do it, because if you open up the DVM module without it being connected, it's going to bring up the connection screen. The other option is to go through the settings and connections and DVM, and you'll go to the same screen. Now, if you never need to disconnect, you will need to go to the settings and connections and DVM. Some of the LEDs on the front, just to let you know, when you turn the DVM on at first, it's going to be solid. It's going to flash rapidly when it's looking for something to pair. And once it's paired up with the field data collector, then it will start blinking about one time a second. For charging, it's going to blink when it's charged. It's going to be solid when it's fully charged. The USB-C is for charging. Again, you can connect that to your Mesa tablet as well. The power button, you'll just hold down. If it's turned on, you'll hold down the power button until it starts flashing and then let it go. And again, this has GPS built into it. So if you're looking at your GPS module within FDC, you will see the source is coming from the DVM. It will give you the last 5 numbers of the serial, last 5 digits of the serial number, and it'll let you know the DVM is connected. So that means all of your positioning data is coming from the DVM. So let's look at the DVM module itself. So when you open up the DVM module, we have several options on here. We can measure volts DC. We can measure volts AC. We can measure DC amps. Now, DC amps requires a shunt. We measure millivolt values across a shunt, and we calculate what your current is. And that's where you're using that 500 millivolt input. We also do AC current, AC amps. And again, it's with a shunt required. So you will need to have a shunt and use that blue 500 millivolt input. So some of the settings inside of the DVM that we can do, if you're in the DVM, you have the gear icon up at the top. And the gear icon is for different types of settings, mainly for setting your method, your survey method, and then setting your waveform options. There's also thresholds. So you can set thresholds on there, which are just simply lines. So I could set an 850 threshold line that shows across my graph if I desire. So if we go into these, right now you see that we are looking at a single reading. So we're in single read mode. And if we go in here and we look at the method, and the method is in single read. Now we can switch that over to GPS sync. So if we are going to do any type of interrupted surveys, this is where we're going to go set our interruption settings here that's going to match whatever our interrupter is doing. So now, once I have that turned on, I'm getting an on-off pair. So I got a 1108 and a 988. I got an on-off pair now. So now I'm looking at an interrupted survey. So if I want to look at the DVM or the waveform now, go to the waveform icon. Now let me say this is, if you're doing any type of interrupted survey, I can't stress this enough, where you're going to start. Before you set up anything, you want to come in here, you want to hook up to your pipe, you want to look at your pipe to soils, and you want to open up the DVM and look at the waveform, because this is where you're going to make sure that you're synced up and you're getting a true on and a true off potential. So we have the first option here, or the first setting, is our on. And in this case, we're 150 milliseconds before the on to off transition. Anytime you see setup, it's going to be before. We also have an off delay, which is 150 milliseconds in this case, after the on to off transition, to get our true instant off or polarized potential. This off delay is the one thing you'll probably move the most. If you're looking at the on setup, the on is usually pretty flat. So you don't really need to adjust that very much, but this off delay, you need to look at that and get that dialed in to where you're getting a true off reading. The other setting on here that's really important is the cycle begins with. So with the cycle begins with, This just needs to match your interrupter. So if your interrupter is set to cycle begins with on, just match it up. You will see if right away, if this is offset. So if this waveform is offset by a second, it's probably your cycle begins with. Most companies will just go with, you know, a single setting. It's either on or off. So you'll match that up. Save a wave print from the waveform. You select the camera icon up at the top, and you will give this a name. Usually you're going to give this, you know, a location. You know, in this case, I've got milepost 216 at Rawlings Road. That way, you know where this was recorded. And then once you save this off, one of the options that you have is you can send this over the air to Survey Manager and import it into Survey Manager. You can bring up your survey. So you have a CI survey and you're looking at the chart and you know this is where this waveform was taken because I'll post in there. I can attach it to that survey chart, and it'll give me a little icon down at the bottom letting me know that there's a waveform tied to this.
Hey, Lon, we actually had just a question a second ago from Mike Hogart. He asked, after setting up a DVM with method equals GPS sync, we have had multiple users report the unit returned to single read. Is there a way to keep it on GPS sync for the entire survey? And then he also followed up that question with waveform tied to inspections, that CIS only or CPDM as well?
Currently, you're talking for a Survey Manager, you'll do that in CI, in the indirect survey. As far as reverting back to single read, it kind of depends on what you're talking about. So if you're in here and you're doing periodic survey, you can apply these settings to the periodic survey. But if you're opening up a CI survey and you're starting that brand new, you want to make sure that the settings in the properties of that CI survey match what you've done in here.
But essentially, Mike, once the button in the upper right-hand corner says apply to, so once you set up the DVM screen to have the settings you like, you can apply that to your periodic survey and it'll actually permanently apply those settings. You could change them obviously internally inside of that app, inside of each one of those surveys individually if you need to make changes on the fly. But this allows you to send your specific voltmeter settings that you prefer, method, cycle time, whatever you need, to your periodic surveys. So it's just in that upper right-hand corner. We'll follow up with anything else you need or any specific use cases, be it David.
Yeah, please let us know. Any other questions?
You have a couple of minutes left, so if you would like to either type your question on the chat or just unmute yourself and go ahead and ask it, feel free to do so. We'll give another minute or so if anybody has any other questions.
Okay, well, it looks like we reached the end of Virtual Brew for October. We really hope to see everyone in the next couple of weeks at Users Group. Again, we're really slated to have a great event, and we're excited to have everyone in Austin. So please, we will do follow-up presentation, and obviously any type of information that we have here, you know, Mike and Paul will take offline and get you answers, maybe more expanded ones you need. And I also see
we had
here
one more question from Kurt. What did he say?
You're absolutely right, Kurt. So you can apply to, either of your survey types if you start in that DVM app. So it does give you a drop down to apply those settings, CI or CI or periodic, depending on how you want things. And you can also be inside of the surveys independently and set up, your DVM functionality as well. So not always tied to have global settings. But like I said, we'll follow up with any type of questions, send links to the tech specs of the DVM, as well as links to the user guide on setting up FDC and the DVM methods that Lon went through. And we really hope you have a great rest of the week and a great lead up to November.
Exactly. So keep an eye on your email for the follow-up. That's usually on Mondays, following the Virtual Brew, where you'll be able to rewatch the presentation today. We'll send links to resources on there as well. And mark your calendars for the last Virtual Brew of the year. It's actually going to be on December 5th, Thursday, December 5th. So it won't be on our usual third Thursday of the month due to the holiday season. So stay tuned for some more details on that one. And you have a great day.
Thank you.
Thanks, everybody.